State is the heart of your application. Really, I challenge you to try to build an application without state. You probably could for a bit, but then there would be a time you would start ripping off your hairs. And yeah, just to reason about the importance of state, just look at all the libraries that exist to manage it. Like, this is just a very, very small example of what we have. But one question that often comes with this type of things is, what's state? Well, state is often defined as a mutable data source that can be used to store data that's relevant to your application. This data can change over time, and it's used to determine how your component renders. Now, let's get a bit into the React ecosystem. And in React ecosystem, there are two given ways to handle state natively. So we start with the use state, which is probably the most easier to understand. And then we get to use reducer. So these things work very well when you're dealing with state that is local to your components. Now, the thing is, this works, but then you start getting into the perspective of, now I need to share my state with other components. I need this state to be handled just outside of my component itself. So this is where context came into the loop. Now we started having a more global way to share state without going into the props department, because then you start prop drilling everything everywhere, and that's a pain in the ass. I said this on the shirt, hopefully. So this is where people, once again, went back into the state management solutions. Heck, probably some of you even skipped doing this thing and went straight to Redux, because that's what everyone else was using at the time. And the thing is, and this is where I want to turn this discussion, is state management often comes to personal choices, personal preferences. You might want to use something, you might want to use something, you might even not want to use state management at all, but that's probably bonkers. And really, try to get 10 React developers together in a room, and after all the discussions about server components wrap up and all the other hype things, or if we should add signals to React or whatever, probably they'll turn their attention to servers, to state management. And like I said, this is a matter of personal preference, because at the end of the day, these solutions are here just to do something, and that is handle or shared state. And this shared state, let's see if the clicker works. Oh, spoilers. This shared state is often referred to as global state. So this is, the thing is that I want you to leave this talk within your mind, is that global state is a container. And this container has different challenges, and it has different ways to be handled. Because global state should be split actually into client and server state. And this is the part where I really want you to focus and think about what we have been doing, how we have been handling our state. Because we have not been paying attention to the right discussion. We have been paying attention of, let's just start with one solution and do everything with that same solution. But because of this, we might be misusing our tools. We might be misusing our solutions, and in turn, we might be wasting our own time. So this is the part where the talk starts. The name of this talk is You Don't Know Server State Yet. I'm Daniel Afonso. I'm the person on the left, in case it's tricky to understand. The other one is my pair programming buddy. I'm a developer advocate at OLX. I'm an Altier ambassador, a Get.io instructor, and I'm the author of the just-released book, State Management with React Query, which might happen to touch on something that we're going to be seeing today, and I'll be doing some giveaways of it. So this QR code said you can all start scanning. It's for, at the end of this talk, I'm going to be giving away 3 digital copies of the book. I also have 2 physical copies, but that's a different giveaway that's going to happen at the end. So this is just in case you don't win one of those, you can obviously still get a copy of the book. Another thing, you can find me on Twitter and pretty much any social network at the handle Daniel JC Afonso. Another thing, if you happen to have been to the sponsor booths already, I work with OLX, and my team has a booth up there. You can go check, talk with them. We have some amazing engineers there ready to answer all your questions and talk about what's the experience with OLX and what tech stack we are using, what are the things that we are doing. So I strongly recommend you to check it out. So now let's get back into the talk, the part of it. So like I said, global state is a container, and this container needs to be split into client and into server state. Why? Well, because they have different challenges. Let's start with client state for sorts. Client state is usually the state that is local to your application. And what does this mean? It means that it only exists into it. So probably if you refresh your page, you will end up losing it. Another thing, this state is synchronous. And because it's synchronous, you don't have to wait to get this data. You can interact with it either via a getter or forgetting the variable itself. And another thing, like I said, it's temporary, very probably. So if you refresh your page, probably all of this state will just go away. Now, this is where we get into the server state part of this talk, because this is where I want to focus right now. Because server state has other challenges compared with client state. But first things first, what's server state? Server state is a state that's persisted remotely, so probably exists somewhere over the internet on a database or somewhere out there. And what does this mean? It means that if you want to get it, you probably need to use some asynchronous APIs to get this data. You have to do a data fetching request because, well, it doesn't exist in your application. You have to go somewhere over the internet and ask for that data and get the data back into your application. What does this mean as well? It means that there's no guarantees that this state is up to date. So the issue with the internet and with getting data from the internet is as soon as you get the data in your code, this data might be stale. It might be outdated. So this means that probably someone else might have updated it. So there are many, many challenges that you have to deal when interacting with this server state. First one is caching. So that's probably the hardest thing to deal with, having to cache stuff into our applications, because we don't want to always be repeating the same requests, or we want to optimize our user experience, and we don't want to get all this data, well, every time. Another thing, and this also comes with an optimization of sort, deduping duplicated requests. So let's picture a scenario that you have 3 parts of your UI that need the same data. So traditionally, what we'd probably do is these 3 parts of the UI could do the same data fetch request, but we don't want to do this. What we want to do is, well, we just want to optimally just fire one request and have that request feed data through all those 3 sources. And this is deduping requests. And other stuff, managing outdated data. So as I mentioned, the data, as soon as you get it, it might become stale. Another challenge, optimistic updates. That's, when speaking about mutations, that's a very common challenge to have. For those of you who are not aware, optimistic updates are the things where at the time you're doing your mutation, when you're updating your data on the server, you're already giving the view to your user of how that UI is going to look after that mutation finishes. So what happens is, at the same time the request is being fired, your user is already seeing how that UI will look. So you're optimistic that that UI will end up being that, what you expect. And then we have a bunch of other challenges like paginated data, infinite scrolling, lazy loading, and many more. Now, imagine having to implement all of these things by yourself. Because that's the feeling that I get when just thinking about doing it. I just want to throw my laptop away and... Because that's the issue nowadays, and the issue with a lot of engineering teams. We often first discuss the solution of how would I build this, instead of thinking, heck, probably someone already had the same issue as I do. Probably someone already went out there, struggled with these things, implemented it, tested it, is maintaining this solution, and probably it's good enough for us, right? That's one issue that happens. And this is what we need for server state, because for client state, there have been many solutions. We have been using Redux for how many years? MobX has been using for so many years. Recently, Zeus 10 started growing more and more and more. But in its essence, these tools are made to handle your client state. And we need something to deal with our server state. And this is where TanStack Query comes into the mix. This is the part where I want to talk about TanStack Query, or React Query. There's a difference, but there's not that big of a difference. But I'm going interchange between both, and I'll explain you why. So what is React Query? React Query, I often like to define it as a protocol-agnostic collection of hooks for fetching, caching, and updating server state. Now, the reason where you might hear it being called TanStack Query or React Query, it's because until V4, it was called React Query. There only was one native solution called React Query that was created by Tanner Winsley. And after V4, he created this amazing thing called TanStack, where he collected all his open source libraries, and he renamed TanStack Query, React Query to TanStack Query. There's also a big reason for that, because you can use TanStack Query with Solid, with Vue, with Svelte, with React. I think there's even Angular out there. And this thing is super cool. There's just one difference, which is the namings of sorts, and I'll try to go over them throughout the presentation, but in a very, very brief way, when in React, and I think Vue, you say use query, use mutation. In Solid and Svelte, you say create query and create mutation. I might be wrong on this part, but I think that was what I was there with the last time I checked the documentation. Now, the next part, we're going to go over of how TanStack Query works and how it solves the challenges that we often have with our server state. And there are just two fundamentals that we need to grasp. There's the queries and there's the mutations. So let's start with the queries. In React, the way to do queries is by a hook, custom hook called useQuery. Now, this hook only needs two things, a query key and a query function. And the way they work, it's fairly straightforward. So let's start with the query key. I like to explain the query key as, especially for React developers, as a dependencies array that you have in your use effect and in certain hooks. So the query key should be treated as all the dependencies that your query is going to need, just so it can render or use for other props. I will explain this a bit better after. One other thing with queries is they need to be arrays. Now, probably some of you that already used React Query out there might be thinking, in my code, I have it as an object. Yes, because probably you're in a version prior to v4. Until v3 of React Query, you could use whatever you want in your query key. It could be a string, an object, an array, whatever. Since v4, it was strongly encouraged to move into arrays, and now with v5, which is in alpha right now, but it's about to, I suppose it's about to be released anytime soon, it's enforced, so query keys need to be arrays. And the second line, as you can see there, that's pretty much how I would describe a query key when I'm building a paginated API. Because as you can see, I have all the dependencies that my query is going to need. It's going to need a page, and it's going to need a filter. Another thing that is super important that I actually forgot to say at the beginning, the query key exists so React Query knows how to cache your data. So once the data is fetched, React Query gets that data and caches it underneath this query key. So this is pretty much the identifier for your query inside of the query cache. Now we're going to see an example of a query function. Here we have GraphQL, just because Roy is on the front line. So here with GraphQL, we have an example of how we're going to be doing a query function. So here we have a GraphQL query, and then in the last part, we have what is called our query function. This is the function that is responsible for doing your data fetch request. And one thing with query functions, and that's the amazing part, and that one thing that really sold me out on React Query, is it's protocol agnostic. What does this mean? It means that you can have GraphQL, it means that you can have REST, it means you can have whatever you want there doing your data fetch request. As long as there's a promise inside of this, React Query doesn't care. It's going to be getting your data and fetching it under the query key. So you define your query function, which should be somewhere here, and you add it into your useQuery hook. So in this scenario, whenever that fetch GQL function runs and gets your data, this data will be cached under the posts inside of the query cache. One important thing to mention here, this thing will run as soon as the component that is using this query mounts. So the first time as the component mounts, it's going to need the data, it's going to see that the query is there, so let's start fetching this thing. And that's an example of using GraphQL. Now let's see an example with REST. But one important thing as well, important thing here, and this is why I make a lot of effort to say, add all the dependencies in your query, because here we have a query, we have our array, and one part, this is a pattern that I like to do, which is in the first position of the array, I add an object which has some identifiers. Why? Because you can pass the query key into your query function. So your query function has something which should be up here, which is called the query function context. And this query function context gives you access to your query key and a bunch of other properties that you might need, but on this scenario are not relevant. And because I have access to it, I can just, here on line 2, I can just destructure the API name from it that I have here, and then use this API name to customize the data that we're going to get. So with this thing, you can customize, you can write kind of generic query functions that don't have a route defined until you instantiate that query. And that's a super powerful thing. So that's pretty much how query keys and query functions work. Now, there are two options that you can use to customize your React query, your use query hooks. And I'm just going to talk about these two because these are probably the ones that have been most confusion online. So just so you're aware, Dominic, aka Take a Dodo on Twitter, he did a poll like a couple of months ago about what do people think that cache time is. Speaking from a context of React query, and in what from what I remember, I'd say like 60 or 70% of people got it wrong. So this is why they've renamed it in V5, but I'll explain what it is first. So, starting with the cache time, aka GC time, since V5 of TanStack Query. This is the duration in milliseconds until your query that is inactive, the data that belongs to that query is garbage collected. So this is a traditional definition, because most of the times when people heard cache time, people would say, oh, this is the amount of time that my query data is going to be cached. Well, in a technicality, it's not, because it's going to be cached after your query is no longer active and until it needs to be garbage collected. So you should always think about cache time, aka GC time, as it was renamed in V5, as the time until after your query that is no longer active, that data is going to persist in memory during that time until it's garbage collected. And that's pretty much how this thing works. The second thing is the stale time. Now, I don't know if you remember, but I told you that as soon as you get your data, there's no guarantees that that data is up to date. And this is when you in your code treat your data as it no longer being up to date, this is when you consider your data to be stale. Your data is no longer fresh. So your data is considered to be fresh whilst you or your code believes that it's up to date to what exists on the internet. So stale time is the duration in milliseconds until a query is no longer considered fresh anymore. By default, this thing is configured as 0, so this means that as soon as you fetch your data, it's going to be considered outdated, it's going to be considered stale, and if your hook re-renders, or if this query mounts in another place, then this data is going to be refetched because it's stale. Now, speaking of mutations, the way you do mutations in React Query is by the use mutation hook. And whilst use query needed a query key and a query function, this one only needs a mutation function, which is the function that is responsible for doing your mutation. It can also receive a mutation key, but that's for another scenario that we're not going to be dealing with here. But let's say that in the V5, it kind of helps dealing with optimistic updates. So the example that we have here, we have in the first 3 lines, we have a create user function. And this function has pretty much an Axios instance that is going to do a post of a user data. Then we instantiate our hook with our use mutation, and we destructure the mutate function. The mutate function is the function that whenever we want to execute a mutation in our code, we just call it and pass it our data. So in this scenario, we're passing a name property and an age property. Whenever we call this function, then this is going to be executed, the mutation is going to run, and hopefully everything will be OK. So now is the part that I'm going to show you some code. So I have to go up these stairs, and I'm a bit scared because I almost fell here. But first, just a reminder, we are still doing the giveaway for the 3 digital copies of the book. So if you still want to sign in, I'll do the giveaway right at the end of the talk. And also, then I'll do a giveaway of 2 physical copies for anyone that wins the quiz that we're going to have at the end, so be prepared. OK, so what I want to show you here, let's just see if everything is all set up. No one else is scanning. OK, so we can head off to the code. So let's show this running first. Here I have an application which is a note adding app. You can add notes, but you cannot remove it. Why? Because I didn't want to implement it. So here what happens is, let's say, for instance, hello, JNation. And let's just remove all these things. I added the note. So once I added the note, I did a post request to the route that I have defined with my data. And then afterwards, this data was refetched as well, so we could update it and see it at the top of the list. If I refetch the page, then the process is the same, but we just have the initial request. And that's pretty much the example that we're going to start with to show how this is built with React Query. So just to recap, we have a list, and we have an input with a submit button. Whenever you submit, data is sent to a server. It's stored into a database, and then we refetch that data to get into our application. So now it's the part we're going to see the code. So what do we have here? This is a React application, and we start with some general imports, a use state, a use query, use mutation, and use query client. I'll explain you the query client in a bit, but what we have next is a const, which is called API-A, which is just there to define one of the routes that we want to hit and get our data. And then we have two things. We have a query function, because it's called fetch data, so I assume it's going to be the function responsible for fetching data, and a mutation function, because it starts with create, so I assume this is going to be responsible for doing some data creation. This fetch data is pretty much the same example I showed you in the, when I was showing you the REST example with the query function. In here, we receive our query key on the query function context, and from it, we go, OK, I want to get the API name, because we know that on the first instance of that query key, we're going to have an object, and I can destructure the API name from it. I then use that API name to customize the route where I'm going to get data from. Since I'm using fetch, I need just to assume, just to check if there was any error. If there was an error, I'm going to throw an error just so React Query can handle this thing for itself, or else I'm just going to return the JSON that my data is going to need. For the create note part, we have a function that's going to receive a note, and afterwards we're going to do a post and send that data over the wire, in this scenario for the API route, just to do our mutation. Now, let's get into the code part. So here we have our demo component, and before we go into some specifics, let's just see something that we have here. So here we have a bunch of divs with probably not very well written CSS, because I'm terrible at CSS. But here what we are doing is we're going to check first if we are fetching, and if we are fetching, we're just going to show a fetching indicator to the user. And once we have that, once we know we are not fetching, and we assume that we have the data, we're going to map over it and show it. And then we have a form, just with a simple input that whenever, just to track our note in there, and whenever we submit, trigger the submit function, which is going to tell the page to not refresh, and trigger our mutation. Now this is the part where we go into our hooks. And let's start with something first, which is called the use query client. Now, one thing that I didn't show you yet and talked about is the query client. Because the query client, let's explain it this way. It's the thing that React Query needs to hold your query cache and your mutation cache and a bunch of other definitions or customizations that you need. So whenever you create an application that needs React Query in it, you're going to need to instantiate a query client first. And this query client is going to be sent to a query client provider so that everything inside of this code can access it and have the access to the same shared cache. And because of this query client is also super helpful. And I'll show you why. But first, let's go into our use query hook. So this use query hook has our query key, which is an array, and then our object with the query identifier and the API name. This API name, like I showed you already, is going to be sent into our query function so we can customize the way that we get our data. And then we are destructuring two things from it. We get our data, which is the data that comes from the query. If we wanted, we could also get the error, if we were handling error scenarios. But on this case, I'm just expecting everything is going well. And then we destructure is fetching. Now, this is something interesting because is fetching is what's called a fetch status indicator. So React Query has two different types of indicators. It has the status and the fetch status. And there's a difference between them because fetch status was only introduced in v3 of React Query. So if you already used React Query, the status things are the loading state, which has been renamed to pending on v5. So just a tip for future migrations, everything that's loading is going to end up being pending. Which indicates that your query is still pending any type of data. It doesn't have any data there. So that's the loading scenario. Then you have the is error, and then you have the is successful. So these are the three states. Now, one thing that these states don't take into account is that sometimes your user might lose internet connection. So you imagine that your user is going through a tunnel or whatever, and they lose internet connection. So on this scenario, React Query is going to stop doing the query. It's going to pause it. And what happens is that your state might be pending, but your query would still be, or would assume to be fetching, but it's not. So that's why this is fetching exists. So fetching is part of the fetch status indicator, which are responsible for telling you about the user connection. So if it's fetching, it's going to tell you that this query function is right now fetching some data. If it's paused, it means that probably you lost internet connection and we're pausing this execution. And if it's idle, it means that it's not doing anything. So you could use these things in combination to do a lot of stuff. In this scenario, I'm just using the is fetching because it's easier to explain on this scenario. And then we have our use mutation. So I'm just going to hide this thing first. And then our use mutation, we destructure the mutate from it. That we're going to use with the onSubmit after. And then we have something here which is called the onSuccess. Now, I don't know if you remember when I showed you the example, but after I did the mutation, React Query automatically went and got the data again. It automatically triggered a query refetch. Because this is what I'm doing here. After my mutation is success, I know that my data that I'm showing to my user, it's not going to be updated. I know that since I just performed the mutation, the data that I'm showing is going to be stale. So this is the part where I have to go in and tell React Query, hey, look there. This query is no longer valid. I need you to invalidate it and refetch something new. And this is where the query client comes in hand. It's super helpful because now you can go to your querying client and tell it, hey, look, the query that's identified by this query key, I want you to invalidate it. And what's going to happen is that now React Query, once the mutation is submitted, it's automatically going to re-trigger that data fetch request so that we have up-to-date data on our UI. And that's pretty much the gist of this more simple example that I wanted to show you. Now, seeing that I still have a couple of minutes, I'm going to show you a couple of other things. Let's start with mutations. So this repository is available online. I'll share it on LinkedIn and on Twitter. But it's pretty much the repository who has all the content that, all the state examples that we have in the book. But so starting with the mutation example, I want to show you the traditional way to do optimistic updates in React Query prior to V5. Because in V5, they just introduced a new way to do optimistic updates. So here I have a custom hook that's just co-location to make this thing easier to understand. And this hook is doing a couple of things. Let's focus on the onMutate callback first. So this onMutate callback is called by React Query, in this case by the useMutation hook, when we have a mutation that is going to be executed. So right before your mutation starts executing, this handler is called. And this is the scenario that we want to, just to remind everyone, want to do an optimistic update. So we want to start showing our user the UI before that UI is committed to the server. So we are optimistic that the server update is going to be OK, and the data that we're going to be showing to the users, well, it's going to eventually be up there on the internet. So we can update our data this way. So how do we do this? Let's start with the onMutate. Once we trigger our mutation, we're going to access our query client. And we're going to check if there is any ongoing query right now for this query key here. So what's happening here? This is the part of we are telling React Query, hey, are you executing any query key for this, any query for this query key? This is just a pattern that I also like to follow, which is a query key factory, which allows me just to have all my query keys into all the same place. Don't worry about it, as I was just showing you. So we cancel any outgoing query for this query key. And then this is the part where we go into our query cache and ask React Query, hey, look, give me the data that you have for this query key. React Query is going to get us that data. We're going to store it, because on an error scenario, we might want to revert to what we had previously. So I'll show you, and then we're going to return it here, because all the things that we return from here on an error scenario that we have here, then we can use it to revert to what we had previously. But now that we have this data, this is the part where now we go into our query client and tell React Query, hey, I need you to update our query data to have the data that I just mutated and the previous one. So this is us optimistically updating our query cache. And if there's any active query consuming this, then React Query is going to notify the query, it's going to re-render, and then we're going to see the new data on the screen. And this was the traditional way of how we've been doing optimistic updates with React Query for many years. The thing is, I've had many issues with this, because as you can see, we are manually changing our query cache. And if we don't know what we are doing, we might end up messing it and kind of making everything worse. And in V5, they introduced a much, much better way of doing this thing. So let's see if I can find the example that I want to show you. So here we have a new optimistic mutation. So how does this work? From the get-go, it's pretty much the same thing. We just have a form with some inputs, a button to submit it, but then we have something different. Okay, this is the state, it doesn't matter. We have our query, which is the query that we are displaying our data to. We have our fetch all data query function, which is responsible for getting this data, and then giving it to React Query to cache it. And then we have our mutation. Now, as you can see, this mutation doesn't have the onMutate callback handler. It only has the onSettled, just so we can invalidate the query after the mutation finishes, just so, okay, now we're going to ask for that data back, just to be sure that we are showing the stuff that is up to date. So, but as you can see, there's no onMutate here. We are not tangling with the query cache. We're not changing anything by ourselves, because this is the fun part of it. Now the mutation has an isPending indicator. And because of this isPending indicator, we know that a mutation is happening. And if a mutation is happening, we can do this type of optimistic update where we just go at this mutation, ask what are the variables of the ongoing mutation, and show it on the UI. So this is much, I assume this is much easier to understand and to explain, because now you don't have to go ahead and mutate your cache. You can just do this thing, add a couple of extra lines to your code, and avoid having to struggle with query cache anymore in the future. A couple of other things that you can also do with React Query. So pagination, it's an example. So previously, there was a custom hook called use paginated query, which was removed in V4, if I'm not wrong, because it's not necessary. This is the example that I told you previously. As long as you have all your dependencies on your query key, you can pass it to your query function and do pagination in that way. So the way this works, and let's start with this use query. We have our query key, which is going to have our page, which is the page that we want to get this data from, our fetch data function, which is going to receive our query key, get the page from it, and fetch the data for this specific page. And once we have it, we receive it and cache it. There are just two other things that we need now to do paginated APIs. Is this thing called placeholder data, which is pretty much something which is a function that we pass into React Query, and this is actually a helper that they created in V5, that we pass into React Query and we tell it, hey, look, whenever you're changing pages, so what happens is, if you change your query key, then React Query knows, okay, I don't have any data for this query key, so I'm going to remove all the data that you have and you're not going to be able to see it. So what would traditionally happen is you would end up with an empty page because there was no data. This function is there to tell React Query, hey, once your query key changes, I want you to keep the last instance of this data before we get the new one. So this is pretty much just a way of, we are still seeing the last page data whilst we still don't have the data for the next one. And that's pretty much the traditional way of doing this. Now we destructure a couple of things. So we have an isPending indicator. So when we are loading initial data, we are showing this to the user. We have an isError scenario. Once there's an error, we show the error. And then once we get our data, for each page, we show the data that we need here. And that's pretty much pagination. Another thing that you might be thinking, you can also do infinite queries. I'm not going to go over this hook because it would take me more time than I'd like to explain it, but it also has a custom hook called use infinite query that allows you to do infinite APIs and stuff like that. So that's pretty much it. Another thing that I've been asked a lot by people now that Remix and Next and SSR starts getting more popular is, okay, but can I still use React Query with it? And the answer is, you definitely can, because most applications nowadays, what happens is you have SSR, you get your data on the server, but in some of them you end up having client-side interactions, client-side fetching of the data as well. So on this scenario, React Query definitely helps you because it brings all the things that we already talked about. It brings the caching, it brings the managing of outdated data. So the simple answer here is, if you're doing client-side data fetching besides the server-side rendering stuff, you can still use React Query. And I'm going to show you an example with Remix of how to do this. So here I have a Remix application. And there are two patterns that you can use with React Query. And they work for Remix and they work for Next. And it works, these things, I tested them both and they work very well. There are two patterns. There is the initial data pattern and the iteration pattern. So let's start by the initial data. So for those of you who are not aware with Remix, a loader is a function that it's going to run on the server that you can use to pass data into your component or to fetch data or do whatever that you want. And on this loader, what we're going to be doing first is just call where it would be your query function to fetch your data ourselves, and then we're going to return it to our component. Once we get that data from the use loader data hook, we use the initial data, which is an option that you can have in React Query to tell React Query, hey, this is the data that I want you to use as the initial data of this application. So when this component renders, the user is going to be seeing this data, and then now you can use React Query the same way you've been using it before. And this is the initial data pattern. Now, there's another pattern called the hydration pattern. And how does this thing work? It's very similar, but now you're not fetching the data by yourself, and we're using the query client instead. So in our loader, which I remind you is a thing that is going to run on the server to get our data, we have access to our query client, and we tell it, hey, I want you to prefetch this query. So we give it the query key, the query function, and what's going to happen is React Query is going to go ahead, prefetch this data, cache it in this query client, and then we do something. I want you to dehydrate this query client and send it to our component. And now what's going to happen is this thing has been dehydrated, so it needs to be hydrated, so when application starts running. So the way these things works now is then in our root of our code, we have something called an hydration boundary, which is going to read from the use dehydrated state hook, which is something that is created specific to handle this with Remix and with React Query. It's going to get your dehydrated state, pass it to your hydration boundary. This is going to hydrate it, and once you get into our code, which should be, let's see, I just lost the page I was in, which should be here. Once you mount that query, now this React Query is already going to be using that query client. So now React Query knows, oh, I had this data dehydrated, so I'm just going to hydrate it and serve it to this client. And this is pretty much the answer that I have for, can I still use React Query with Next or Remix? You can, if you have query, especially if you still have query client-side data fetching. And that's pretty much it. We still have 10 minutes, but I still want to do the giveaways and do the quiz. So what's going to happen now is, let's see how this thing works. Let's try this out. We're going to do a Slido trivia stuff, and the winners we're going to have 2 books written by me, I think, called State Management with React Query, and I'm going to give away 2 books. 1 book to each winner. So the first 2 winners are going to get the book. So what I'm going to ask you is, if you want to participate, scan this QR code and start joining. Then we're going to have a couple of questions to see if you were paying attention to this talk. I think I can go to the next one. The QR code is still there, and we can start seeing the name of the people that are joining. Okay, there's already 20 people here. By the way, I didn't tell you, but this Slido can only take 100 people, so if there's more than 100 of you out there, I can't count these many people, but okay, 63, 65. I'm going to give it 20 more seconds. Okay. Is anyone still trying to join? Okay, there's 1 person there. You have 10 seconds. Okay, so let's start this thing. So this is comprised by 6 questions about my talk and a couple of other things. So, according to this talk, how should you split your global state? Client state and server state, UI state and server state, user state and server state, synchronous state and asynchronous state. Let's see those answers. We have 5 seconds to spare. 2, 1, and let's see those answers. Okay, at least 89% of you were paying attention at the beginning. Amazing. So we have our leaderboard right now. RNF is in the first place, and we have Guilherme on the 2nd place. But there's still a couple of questions to go. Who created React Query? Was Ryan Carniato, was Tanner Winsley, Kenzie Dodds, or Roy Dirks? I'm just taking advantage that both of them are here as well. Let's see if you paid attention on the specific part of the talk where I mentioned the name of the creator. Let's see those answers. Okay. Congratulations, Ryan. Congratulations, Roy. You also had a part in creating React Query, but the right answer is Tanner Winsley. On the leaderboard, we still have RNF in first place and Loureiro now in second place. What are the main hooks of React Query? Use query and use mutate, use queries and use mutation, use query and use mutation, use queries and use mutate. Let's see what comes out of there. This is the part where a fun music or something would be cool. But I didn't implement that thing. Okay, let's see those answers. Okay, the majority of you got it right. The first one was the couple. This was just made to confuse all of you and see your attention. Let's see your leaderboard. Okay, so now we have Vasco Borges in the first place and Rafael on the second place. Can I use SOAP with React Query? Yes or no? Let's see those answers. I have 10 seconds, 9 seconds. Let's see what shows up here. Question is, do people still use SOAP? But yeah, the question is yes. It's protocol agnostic. As long as you can wrap this thing in a promise, you can use whatever you want. Next answer. Oh, no, leaderboard. Now Rafael is in first place and Vasco Borges in the second one. This is going to be a fun competition. What is cache time? Let's see you paid attention to this one. Is it the time that your query data will be cached? Is it the time until an inactive query data is garbage collective? Is it the time your data is considered fresh, or the time until an inactive query data is garbage collected? Let's see you paid attention to the slides. Let's see what we have there. Okay, 69% got it right. The second one was there just to see who clicked it first and got confused with the reading. Now we have Rafael in first place and Dario in second place. Oh, this is being fun. Now we're going to the last question. And let's see who was here last year. What was my talk at JNation 2022 called? Imposter syndrome-driven development, React hooks broke my tests, now what? All you need is a contract or React remixed. Fun fact, these are all of these talks are talks that I've given at a point or other. So let's just see who was here last year and remembers what did I talk about. Okay, so the majority of you got it right. It was indeed React remixed. So let's see who were the winners. We have Dario and Viegas. Where are you? I'll go give you the book. So let's see if I don't fall on these stairs again. One there. Oh, Viegas, okay, cool. I know him. But he didn't know the answers before, I promise you. Oh, feedback. Congratulations to both of you. Congratulations. Now, we still have 5 minutes, so I'm just going to do the digital copies giveaway as well. So if you didn't win now, you still have an opportunity. So now this is the part where I go into here. Let's see your responses. I'm just going to copy all your names. Let's side. By the way, if any of the people that won the book now still win, they are disqualified, by the way. So let's see if this thing works with so many names. Oh, wow. Let's roll this thing. Let's see who's the first winner. André Araújo, so he's the first person. You will receive an email then from my publisher with your copy of the book. Let me just take note of this. I'm just going to add this on VS Code, hard code it. The next, let's remove André from here, and let's run it again. Let's see who's the next winner. Oh, Eurico Correia. Okay, congratulations. I will also send you an email. And now to the last person. Let's see what comes out of here. Oh. Okay, Margarida Pascoal. Congratulations, you also receive a copy. And with that thing, I just want to go to the last closing thoughts of the talk. That we should have here somewhere. Now, speaking of React Query, as you can see, there are a lot of challenges that it fixes and it deals with it. Caching, it does it thanks to the query key and to the query cache. Deduping duplicated requests. I didn't show this on my demo, but trust me, it works. If you have the same instance of the query running at the same time, React Query is going to cancel one of them and feed the data that it comes from it to the other ones. Paginated data, you saw it working. Managing outdated data, it does it manually as well. We did it manually by using invalidate query and cancel query, but it also does it by itself thanks to the stale time property. Optimistic updates, we saw the traditional way of doing it and even the most recent way of doing it. Infinite scrolling, lazy loading, scroll restoration, offline support, and data prefetching. These are all things that were not, some of these things that were not on the initial slide, because React Query can do this thing and many, many others, and it keeps growing more and more and more in every week. When I started using React Query like 3 or 4 years ago, it was still very recent, and it's been amazing seeing the experience of it growing, seeing the experience of how Tanner and now Dominic and all the team behind it have been contributing for it. So hopefully by now, all of you know a bit more about server state. I'll be around the venue for questions, and you can meet after. Thank you so much for joining.